We're on.
Good. Anybody signed up?
Yep,
Okay,
they're coming in. Hello, everybody.
and welcome. We're going to be talking about this book, Everyday Electricity from Heron Books. And with me today, my name is Marty, and I'm the science teacher here at the Delphian School. And with me today is my friend Sam. Sam's going to be fielding questions and helping me run this video. So if you have any questions that you'd like to ask, there's a Q&A at the bottom of your screen. That's what you click, and Sam can let us know what the questions are, and hopefully we'll be able to get to them while we're live and broadcasting. So welcome to this broadcast. We're going to be talking about parts of the atom first, because we're going to be talking about electricity, and electricity has to do with parts of the atom. So here is a picture of parts of the atom, and there's protons, which are positive, and neutrons, which are neutral. They're neither positive nor negative. And these little tiny electrons, which are negative. And so these electrons, the movement of these electrons is what makes electricity. Now, of course, this is not the real size of atoms. They're incredibly tiny. Okay, so electrons, when I say positive and negative, that's just a name that scientists give these parts to let you know how they react with each other. So like a magnet, if you have a negative and a positive, they attract. But if you have a negative and a negative, they repel. Or if I switch them both and you have a positive and a positive, they repel. Now, there's a similarity, of course, in magnets. We're not talking about positive and negative. We're talking about north and south. But there's a similarity. There's a connection between magnets and electricity. So electricity is just when you have an electron. Don't forget, electrons want to get away from other electrons. And if this electron gets close to that, oops, I had it the wrong way. If this electron gets close to that, did you see it push it away? Well, that's what electrons do. Yes, Sam?
I just said, wow, that was cool.
Oh, that was cool, okay. And so you have things that control these electrons. For instance, you can see it here. We're going to be using batteries and wires today, and here's this wire. You can see it's metal at the ends, but then this is a clear plastic covering, so you can see the metal wire. It's copper, which is a metal. It's what pennies are made of. It's a copper wire in the middle, and this is what allows electrons to move, which is what electricity is. Now, some metals are magnetic. So for instance, this spoon is magnetic. This iron alligator clip is magnetic. This piece of wood is not. And similarly, metals will let electrons move through them. What's called a conductor will allow electrons to move. Because metals, like this spoon, have electrons in them, but they're holding onto them not very tightly. Things like this piece of wood are holding onto the electrons tightly, and they won't let other electrons push them around. So I'm going to show you a couple of different circuits. Now, a circuit is like a circle of electricity. So if I have a battery and I attach it to here, to this light, and I get a second battery here, and I attach it so this is from the negative to the battery, from the battery, negative, and it's going to go to the positive here, but it doesn't light up. Why do you suppose that is? It's going from the negative, which is where the electrons are, through here to the positive of this battery, but the light's not lighting up. That's because it's not a circuit. It's not a circle.
Marty, let me interrupt for just a sec. Jacob, you had a question. I'm not sure what it is, but if you type it in, we'll get you an answer, okay?
So, thank you, Sam. So if I make a circle out of this and attach it, now we have a nice bright light because we have a complete circle. A circuit, it's called. And just like you might have seen this from my last video, there's a little battery in here. And if I touch one end, nothing happens. But when I touch the other, it's lighting up because I'm making a circuit. I'm completing the circle. Okay. You might have seen some other switches. Switches control the electricity. Here's an example of a switch. So I could take this and attach it here and attach it here. And then when I press this down, it completes the circuit and you can get the light to work. Now the lights, these switches you're probably used to look something like this. This is a light switch. Let's see if it'll work. I attach one end here. I'll attach this back to the light bulb, and I'll attach this end here. And now I'll turn the switch, and it works. This is the type of switch that you might have for your lights at home. So I can shut the lights on or off, just like you can at home using this switch. This is a very powerful switch, though. This can stand a lot of electrons going through. Okay, I wanted to show you one other kind of switch. I don't know if you have a dimmer switch at home, but a dimmer switch can make things very bright or not so bright. So I'm going to attach, this is what my dimmer switch looks like. And I'm going to attach it to the metal here. And the metal there. And you can see it's on a little bit. And I can turn it and it gets brighter, or I can turn it and it gets dimmer. So this is your dimmer switch. And the way it works is it increases or decreases the amount of electrons that are flowing through.
Good, Marty, just one sec. I want to remind everybody, if you have a question, put it in the question and answer section. Don't use the chat. Okay? Because I'll be checking the question and answer. The chat I can't quite see as we keep going. So go ahead and put it in the question and answer section. No problem if you've been using the chat. But let's move over to the question and answer section, okay? Good.
Thank you, Sam. So this is some wire that I got from a hot air gun, from a hairdryer. You know, when you turn on a hairdryer, you see these things and they glow. And the reason they glow and they get hot because the electrons are going through and this gets hot. And so this has resistance in it. And so if I attach them close, you can see light bulb lights up pretty well. But the further back I attach it, that might be a little dimmer. You could see it getting a little dimmer. You could see it getting a little dimmer. Let's see if I have it at the very end. Oh, it's hardly on at all. I don't know if you can see that at home, but it's not very bright. So that's how the variable resistor, the dimmer switch, works. It can add more resistance or less resistance. And resistance is just slowing things down.
Good, Marty. We have a couple questions. Is it a good time for a couple questions?
Sure.
So one of the questions is, what are atoms for?
Well, atoms are for everything. Atoms make up the world that we know. They make up the table. They make up our bodies. They make up the books. They make up things. The world is made up of atoms. I don't know if you've heard my joke before, but I'll tell it again because I like this joke. Never trust an atom because they make up everything. They make up everything in the physical universe. They don't make up thoughts or ideas, but they make up spoons and tables and chairs and bodies and that sort of thing.
Great. Another question was, how does the switch work?
Well, that's a great question. So if you look on the bottom here, you'll see this is metal, and metal conducts electricity, and it's attached to this. And again, this is metal. And when I push down, this metal is attached to that metal. And look at what's happening under here. There's this little bridge. You could even see it on top. So the electrons go from here through the metal, through here, through this. It's attached. You can see how it's attached to the back. And it goes through here, and it lets it move. The metals let the electrons move. That's how this switch works, and that's how all switches work. They can either shut it down, shut down the flow, like if I have this little gap here, then the electrons can't go from here to here. So this stops the electrons from flowing, and the light doesn't go on. When I move it down, then the metal connects with the metal, and it completes the circuit. Just like if I have this here, there's a gap. So if there's a gap, then the electrons can't move all the way in a circle. But if I touch them, now there's not a gap, and the electrons can move around in a circle, and that's what makes the light light up.
Good. A couple other questions.
Sure.
They're coming in hot. So somebody asked, what is a circuit?
A circuit. So that's just a circle of electrons flowing, electrons moving. Remember, they want to get away from each other. So in a battery, there are chemicals, and what these chemicals do is they make a lot of electrons hang out over here, and not many electrons hang out here. A lot of protons hang out here. And so the electrons want to go, just like in our magnets, they want to go from the negative to the positive. The electrons want to go from here to here, but they can't. They can't go from here to here because there's air. Air does not conduct very well. But the metal in here does conduct well. And so when I attach them, the electrons from here go through here, through the little light bulb, lights it up, comes back here. Also, it can get back and complete the circle or circuit.
Circle, like circuit.
Like circuit, circle. Here's a picture of electric current is the flow of electrons from negative, which is where the electrons are, through our battery here. And it goes through this wire, this metal wire that conducts electricity to the positive side of the battery.
Perfect. Now somebody asked, why aren't we able to see the atoms?
Well, we're not able to see atoms because they are incredibly tiny. Let me give you an example of how tiny they are. Scientists believe that there are 200 billion stars in every galaxy.
200 billion.
200 billion. And they believe that there are 200 billion galaxies. So you have about 200 billion stars in a galaxy and about 200 billion galaxies. So when you multiply those together, you get a great big number, right?
Yeah, really big.
You have more atoms in your little finger than all the stars in all the galaxies in the entire universe.
Wow.
That's how incredibly tiny these atoms are.
That's a pretty good answer.
Okay.
That's pretty small. Do you want to take a few more questions?
Sure.
People are pretty excited about some of this. So somebody asked, how does the dimmer switch? Well, what is a dimmer switch? And then how does it control the amount of electrons going in the circuit?
Well, that's going to lead us right to the next thing that I'm going to speak to you about,
Perfect.
which is Ohm's Law. So it was named after this man named Ohm, and it's not a law that the government passed. It's a law that explains the way electricity works. And there are three parts to Ohm's Law. There's voltage, which is like the push, how hard the battery is pushing. So if I had more batteries, this is a 6-volt battery. If I had more batteries, it would have more push. And then there's the current, the flow of electrons. And here's something, you see this little space here, this narrowing, that's resistance. That slows down the flow of the electrons. This is the electron flowing. He can't go as fast because he's being slowed down. So what happens is when you have resistance, like in this resistance wire, remember we showed you how the light got dimmer and dimmer the more we used from this wire. Well, similarly, the variable, here it is. This is called a variable resistor. Variable just means changeable. So this is a resistor, and the more I turn, it can change, increase, or decrease the amount of voltage. So I'm just going to hook it up again and show you. So right now there's a lot of resistance, so much resistance slowing down these electrons. There's not enough push here to light up my little light. But if there's no resistance. Now there's a little resistance. You see how it gets dimmer? The light gets dimmer and a little more resistance. So resistance slows down the flow of electricity. And there's something else besides a dimmer switch or this resistance wire from a hairdryer that could slow down the electrons, and that's another light.
Good, Marty. Somebody wanted to know, what is a resistance wire?
Oh, well, I'll tell you that in a minute. So here, well, look at how bright it is with just one battery. And now with one battery, and now with two lights in there, it's a lot dimmer. And if I had another light, and I bet I do somewhere around here. Here's another one. If I had another light and I attached it, look at how dim they are now. They're barely lit at all. So why is this resistance? Is that the question?
It was, what is a resistance wire?
Oh.
I think you'd used the word resistance wire, and somebody was
Well,
not sure what that meant.
this is a wire, and I got this wire from a hairdryer. Now, I don't need a hairdryer all that often. So I took my hairdryer and I opened it up and I took this wire out. So what happens is when there's a lot of resistance, it gets hot, the wire gets hot. And so that's the purpose of all of this wire. This wire is inside a hairdryer, and it's wrapped around like that, and it gets hot. And then there's electricity is going through it. And then there's a fan that blows air, and that helps dry your hair. Because this gets hot, the fan blows, and you get hot air to help dry your hair. So that's where I got this resistance wire. This is just a wire that has a lot of things in it that slows down the current, the flow of the electricity.
Good, and then a lot of people are asking the question, what's the difference between a positive electron and a negative electron? Or I think you'll explain that.
Okay, so electrons are negative and protons are positive, and they could have used other names for them. They could have called them Fred and Alice. They're just words that are telling you how these particles or parts of an atom act. So the negative and positive, or Fred and Alice, attract each other. But if you have Fred and Fred, or negative and negative, or even south and south, they repel each other. So they're just names to let you know what these different parts are, to let you know how these different parts react with one another. That's all they really mean.
Perfect. And somebody asked a really interesting question, which you might want to not answer for now, but you might.
Okay.
Somebody said, how could something so tiny create such a gigantic explosion?
That's a great question. You're talking about a nuclear reaction. So what happens in a nuclear reaction is you have an atom here, and there are two types of nuclear reactions. One, you have an atom here and an atom here, and they come together to make one big atom. That's called nuclear fusion, and that's what happens on the sun. And when these two combine, it makes a tremendous amount of energy. So that usually on the sun, you take hydrogen and hydrogen, the smallest atoms are hydrogen, and you take them and you make the second smallest atom, which is helium. And that's what happens on the sun. And on all stars, what happens, the other nuclear reaction, I mentioned there were two, the other type is called nuclear fission. And what that means is it's broken up. You take an atom, a large atom, uranium is the largest naturally occurring atom, and you take that, and usually nothing can get through it. But scientists figured out a way to get this neutron and smash it into a uranium atom. And what that does is it breaks it apart. And when it does that, it lets an incredible amount of energy out. Einstein, a very famous scientist, wrote this formula, and it tells you that a little bit of mass, a little bit of the material universe can be changed into a tremendous amount of energy. And he said, and this is fascinating, he said, matter, like this spoon or table, is just energy that's really squeezed together. And it's beyond what we're going to talk about today, but it's a great question.
Great. And then one last question that a lot of people are asking.
Yes?
Is can you see protons, neutrons, electrons, and atoms? Is it possible to see those with any equipment?
Well, I've seen pictures of atoms taken with a special microscope. And these atoms are the largest, uranium, the largest occurring atom. The picture looks like this, a little dot, when it's magnified over 5 million times. So you could have 5 million uranium atoms in this little tiny space you see there. That answered their questions.
I think so. And then, sorry to keep interrupting, but they have so many questions. And this was a really good one that many people are asking.
Great.
They're asking, aren't our bodies made up of cells, not atoms?
Right. Our bodies are made up of cells. But what are cells made up of? Well, if cells are part of the physical universe, like this table and this spoon, they're made up of atoms. This spoon is made up of atoms. This paper is made up of atoms. The battery is made up of atoms. My body and your body and the cells in our bodies are made up of atoms as well. Incredibly, incredibly tiny, tiny parts of matter.
Perfect.
Okay. All right. So we're going to talk briefly about insulators and conductors. Now, when I'm talking about a conductor, I don't mean the guy on the train that takes your ticket. I'm talking about something that will let electrons go through and something that won't. So metal, for instance, the metal wire in here are good conductors. This is a good conductor of electricity. So if I took this spoon, what do you think is going to happen when I attach this to the other end? It conducts, because metals are good conductors of electricity. Now, if I have something else, oh, here's a nail. This is also metal. So if I attach one end here and the other end here, it's also conducting electricity. But if I attach something that's not magnetic, like this sheet of paper, or that doesn't conduct, one there and one there, nothing. We don't have any electrons flowing because this paper holds on to their electrons tightly. Remember, metals hold on loosely. And so, just like with a magnet, when an electron gets close to another electron in a metal, it pushes it away. And then this one gets close to the other one and it pushes that away. And you get this flow, like a flow of water, except this is a flow of electrons in the metal wire. Okay. We can take a couple more questions, or I have a couple of more things to discuss.
Why don't you carry on? I'm answering some of the questions in the chat as well as I can, and we might pause in a minute and answer a couple more.
Okay, so now I'm going to take 2 batteries. Here's my second battery, and when I attach it, I go from the positive to the negative. And now, you remember what 1 looked like? This is what 1 looks like when I have 1 battery in the circuit. And here's what happens when I have 2. Holy cow, that's bright.
Wow.
And that's bright because I have more push. So if we look back here at our Ohm's Law diagram, you could see there's like 2 of these guys pushing now. And that's making the electrons go through faster. And that's why it's brighter. Now I want to talk to you about something called parallel and series. So this is a series. It goes from one to the next to the next. But I could hook this up. Let's see. I'm going to hook this up like that. I'm going to have this going to here. And this going to here. And now it's not as bright because I have 2 of these that have to be lit up. So this is called series. So it's going around, but there's more resistance. Remember, these light bulbs make resistance. Now, if I hook it up differently, this one up here, and this one up here. And then this is going to go here. Now watch what happens. Whoa, both of them are bright. So that's the advantage, and you can see how these lines are, these wires are parallel. Parallel means never touching, they're going in the same direction. And so that's what happens here. These are in parallel. And the advantage of parallel is if one of your lights burns out or stops working, the other one still works. So the advantage, if you had Christmas lights and they were in series, let's put it back here in series, so I'll show you how that works. So if you had Christmas lights in series and one of them burns out, you don't know which one it is. You might have 50 lights or more, and you wouldn't know which one it is. But if it's parallel, then they'll all light up except for the burned out ones, and you could just replace that. Another advantage of this parallel wiring, you have parallel wiring at home. So if a bulb goes off in your lamp, it doesn't shut the TV off because of the way it's wired in your home. How are we doing, Sam?
Great. I'm just answering questions here.
Okay.
A question that keeps coming up is about protons and neutrons. I thought it might be good to draw a demo of an atom. That way maybe you could use the screen or...
Well, I have a demo of parts of the atom here. So remember, here's the nucleus or center. And remember, these are incredibly tiny, tiny. And this is just a drawing of it. And it's based on a lot of experiments that scientists have done. And so the positive protons are in the middle, and the electrons are circling very fast around the edge. But they're very tiny. I mentioned before that if this atom were the size of a baseball field, then the nucleus with the protons and neutrons would be like a marble behind second base. And these electrons would be like pieces of dust in the outfield. So an atom is made up mainly of empty space. There's a lot of empty space. It's very, very tiny. These atoms are very, very tiny, but they're mainly empty space. I think that's just incredible.
Perfect. Good.
Okay. Do we have time for one more thing, Sam?
Yeah, we have a little bit of time left. Let's move on.
Okay, I'm going to show you this. Some of you are familiar with this type of light. This is called an LED. And so, if I had a button battery, like here, and I attach it, nothing happens because LEDs stand for light emitting diode. A diode is a piece of electrical equipment that only lets electricity flow through one way. It doesn't let electricity flow the other way. So if I turned it around, now it lights up.
Wow.
So that's what diodes, you've probably seen this. There are flashlights that are made up of diodes, and car brake lights are made up of these diodes because they turn on immediately and they only let electricity through one way. Okay. There's one other thing we could talk about.
Yeah.
And, well, there are lots of things we could talk about.
Do you want to answer a couple questions?
Sure, let's answer questions.
We have a lot of questions rolling in. So a lot of people want to know if magnets conduct electricity.
Well, let's see. So if I attach that,
This is a great way to test this.
yeah, so here's a magnet, right? And I'm going to attach it there, and it doesn't. It
Interesting.
doesn't. Now, if you had a magnet made of iron, then it could conduct electricity. But this isn't iron. This is another kind of element, and it doesn't conduct electricity. But let's see this guy. This guy, I think, is a metal. So, but it's a battery. It's not a magnet. Yeah, it's a metal. And metals conduct. But that's a great question. These magnets are not metal, and so they don't conduct electricity.
Awesome. And then somebody said they've heard of this thing called short circuiting.
Yes,
And I wanted to know if you could explain and show what short circuiting might be.
great question. So here, the electrons are going from here, from this battery, through the wire, lighting this up, and going through here and through the wires and lighting this up and back, and we have this circle. So it's a circuit. Now, a short circuit just means, I'm going to show you on one. I'm just going to put one of these in here. It'll make it a little easier to understand. So a short circuit, right now these electrons are lighting that up quite brightly. And the electrons are doing a lot of work pushing through the resistance that's here. But a short circuit is when something happens and the electrons don't have to do any work. They just go from the negative to the positive. So if I touched this side and this side of the light bulb, it stopped glowing because the electrons would much rather not do any work, would just go right from here to here and go back this way. And if you make them do work, they will, because they really want to get back to this positive side. But if you give them the opportunity to go from the negative to the positive without doing any work and pushing anything, that's what they'll do. And that's a short circuit. If I took this wire and attached it to here, that would be a short circuit, and this wire would start to get very hot and maybe even start to burn. So short circuits can be dangerous, and they can start fires.
Great question. Let's see if we have any other questions that we have time to answer. So somebody asked an interesting question that I'm really curious what the answer to is.
Me too.
They basically said, what is a diode? They said, if something's battery powered, does that mean it's a diode? What makes a diode a diode?
A diode is a part of an electrical, a piece of electrical equipment. Now, I'm going to show you this. Here's how big power companies, this is a model of how big power companies make electricity. Here are two magnets, and here's some wire wrapped around this bolt. And when I turn this dial is showing you that I'm making electricity. And the electricity is going this way, and then the electricity is going that way. Now, in a battery, it always goes from the negative through the circuit back to the positive. But it just so happens here, let's see which one this is. So here is this type of current, the one that changes direction. Remember, current is just the flow of electrons. So here, if I attach it, it lights up. If I attach it the other way, it still lights up because it's only letting the electrons Remember, the electrons go through that way. It doesn't let them through that way, but it changes very rapidly. Now, if I took, that's called alternating or changing current. Here's another one, which is direct current. That means it's like a battery. And if I attached it here and here, it lights up. But if I attach it the other way, nothing. So there are some things, like a light bulb doesn't really care if the electrons are just moving in one direction or if they're moving back and forth. Light bulbs don't care. But things like computers do care. So if you have a computer and it needs to have one-way kind of flow, and you start with something like this, then they just put a diode in there and there, and then it only lets it through one way. When it goes the other way, if you look at this very carefully, you could see a little on and off, but it's very hard to see. Anyway, it's just letting the electrons through one way. When the electrons go the other way, it doesn't light up. But because it's happening so many times a second, you can't really see it.
Good. Now, somebody really wants to know the answer to this question. What are magnets made of?
Magnets are made of all kinds of things, but I'm going to show you, we're going to make a magnet right now.
Awesome.
So this magnet that we're going to make is made up of these little pieces of iron. That's what I have in here. And you can see this is a compass, and compasses are attracted to.
So if you can see, it's just little, it almost looks like sand in this.
Right.
Just little tiny pieces.
And compasses are attracted to magnets. And so if I took this and I'm shaking them up, and nothing's happening here, because magnets have these little parts in it. I think I might have a picture here. Yeah. So here's what we have so far. We have these little parts, little tiny magnets inside, but they're going in all different directions. It's like you're in a boat and somebody's paddling this way and somebody's paddling that way and someone's paddling this way, and you're not going anywhere because you're all paddling in different directions. But when I take a magnet and I run it over these little parts that are pushing or paddling or pointed in different directions, and I have them pointing the same way, then it turns into a magnet. Let's try it. So we already saw that this is not magnetic. Okay? Now, I'm going to take this magnet and I'm going to just line up all of these, some of these pieces, especially at the bottom here. So now they're all going to be going the same way. And now,
Wow, look at that.
what's happening? Can you see it? It's now attracted because they're all lined up the same way, and this is what makes a magnet.
Wow.
There's something called an electromagnet, and what that means is it's these wires, metal wires, and right now you can see it's not really magnetic. But if I attach it to a battery and there's electricity running through it, it lines everybody up just like that. Watch. So now, can you see? It's lining things up and it's attracting, but if I disconnect it, Now it's not a magnet anymore. It's not really attracting this. It's only a magnet when there's electricity running through it, and this is called an electromagnet. It's only a magnet when electricity runs through it. As a matter of fact, I'm going to show you one more fun thing. Here's wire, but there's no metal bolt in the middle. So I'm going to attach this to one end. Now this is red wire, and this red is a good insulator, and it doesn't let electricity through. So what I had to do is I shaved
So inside that is a
inside
wire.
is the copper wire, the metal wire.
Cool.
So I just shaved the outside of it to where the electricity can go through. So if I put this here, it's not a very good magnet. But oops, well, it's not a good magnet because this isn't attached. Let's try that again. Should see a little spark here.
Yeah, look at that.
Now,
It's got a little bit.
a little bit,
Not much,
but watch
no.
what happens. I'm going to take this and I'm going to put it down right here on the table. And I'm going to put this just a little inside here. Now watch what happens when I connect it. Watch the nail.
Whoa.
So this nail got pulled inside there because now it's going to be, because there's an attraction that it had. And now look at what a good magnet it is. Not such a good magnet. When this is inside, much better.
Wow, that's cool.
So what happens is, just like in our, with our test tube full of these pieces of iron, we got things lined up. When the electrons go through here, it lines up the particles so they're all pulling the same way.
Good.
Without them, it's like that.
We're out of time, people.
We're out of time.
actually
Thanks for
2 minutes
joining us.
over.
I hope you can join us again next time. We'll see you soon.
Good, and then Marty, show them that pack, because this is available. You can download it online.
You can download this free online, and you could download a study guide that'll give you the step-by-step things you need to do. You can do a lot of these experiments at home and learn more about electricity. Remember, curiosity is the solution to boredom. So I hope you stay curious and find out more about how the physical universe operates. Thanks for viewing. See you next time.
Great, thanks for being here, everybody. We'll see you again.
Bye.